Hello everybody. In this video we're going to do a review and example of loading our collections asynchronously. Let's take a look at our code. I've started by creating a static class representing our JSON service. We've got a file name pointing to a very large collection of invoice items in JSON format. And I've got two methods, one for retrieving the collection and another for saving it. So the retrieval method reads the text from the file, converts it to a list of invoice items, and then returns that list. The save collection method does the opposite, takes our list, converts it to a string in JSON format, and then writes that string back to the file. Both of these methods are written to run asynchronously, which means that when we call these methods, we should use them along with the await keyword. Using async and await is a way for us to create another thread so that when our data loading is taking a long time, it doesn't block our user interface from continuing on with its load pattern. So this can be very helpful, especially when you're retrieving large amounts of data or data from databases or web services or other places that might cause it to take a long time. So while we're waiting, we don't want our application to become unresponsive. That's not a very good experience for the users. So we want to run the data collection in a separate task, which creates a new thread separate from our UI thread. The problem is sometimes we need our UI thread to use these things from the loading. So we need to make sure that they can come back together in a way that allows our app to load properly. So let's take a look at our invoice collection page. This page is bound to a collection of invoices. It also has some entries at the top so that we can modify part of an invoice, its description, quantity, or price. Inside the data binding of the collection view, we've got edit and delete buttons, both of which call on a command that interact with that specifically selected invoice item. Also on this page, we have a count property that is bound to item count. Let's take a look at our view model. Our view model contains these bound properties: the collection of invoices, description, quantity, and price for editing purposes, and the item count, which is a dependent property. The item count property depends on our invoices collection by asking it for its count property. In a previous example, we have instantiated invoices just here as a hard-coded temporary list of invoice items. After the invoices collection has been created, we also added this event handler to the collection changed event so that our item count property would refresh when the collection has changed. We're going to change our invoices assignment to call on the method from our JSON service. We want to use our getDataCollection async method. In order to use this method, we'll just comment out that previous code for now. What we want to do is set our invoices to a new observable collection, and inside of the parentheses, this is where we can generate our list of items. And if our list of items is coming from our JSON service, getCollectionDataAsync method. However, this method is an asynchronous method designed to be called with the await keyword. Unfortunately, we can't await inside the constructor because the constructor is not an asynchronous method and we are not allowed to use the async keyword in the constructor heading. Now we have a solution to this. We can create a task and assign the task to an asynchronous method call. If we have a method that returns a task object, that method can be made async, and then we can put the await keyword along with asynchronous method calls into that async method. So let's create another method that we can use to call this async method. we're going to create a task return type on this method. So that when this is completed, we can pass the task back to our constructor. Let's move this line of code out of our constructor and into the task method. Now what we need to do is assign this call to a task property. For now, I'll make it a private read-only task field. So here's our loading task, and we're going to assign load task to the result of loading our invoice items. So this looks like it's going to work. Let's run it and find out. Uh-oh, we've got an exception. The exception that's thrown here, saying object reference not set to an instance of an object, the problem is that our item count property references a null, and the reason why it references a null is because the invoices is a null as well. So the problem here is that, yes, we have offloaded the task of generating the invoice to another thread. However, our main UI thread continues. It continues by attempting to set up the rest of the ViewModel. So it bypasses the setup of invoices, which is still null. We're still in the process of reading those invoice items. I made the JSON file really large so that it's going to take a little bit of time. So if invoices is null, invoices.count is going to reference a null and cause item count to throw an exception. Now there's a few ways that we can solve this problem. The first solution might seem like an obvious one. We can say if invoices is null or count doesn't exist, then why don't we just return a 0 to start? And that would work. The problem is if we do that, when the page finishes loading, we're going to see our enormous list of invoice items, but our count is still going to show 0 because the count will have been set before the invoices are finished loading. And that value is never updated until the invoice collection changes again. Finishing loading is not going to raise the collection changed event. So the problem here is things are happening out of order, and we're trying to use invoices and other things that depend on it while it's still being loaded. The solution is just to refactor the code to make sure that code that uses invoices is not going to be called until after the JSON service has finished getting its collection data. So let's take also this line of code and place it into our load invoice items task. Now item count will not be referenced until after the invoices are finished loading. Or so we might think. Unfortunately, the loading of the item count is still becoming a problem, and the reason why it's becoming a problem is because of our ViewModel being assigned to the page. So item count and invoices now are both kind of waiting for this to be done. However, if we think about what is loading up the ViewModel to begin with, it's actually the dependency injection. So let's take a look at the code behind for our invoice collection page. This is the view. Instantiating the new instance of invoice collection is because we're trying to assign it as the binding context of the page. This is unfinished, so when we're trying to assign the binding context, the ViewModel is still being built. We're continuing down this thread and building the rest of the binding context while the ViewModel is still initializing itself. And this is part of the problem with threading in applications to begin with, is that things are dependent on other things. So if you're going to break your application into threads, you have to consider how that's going to affect the calling locations of these. And usually what we say is if we're going to use async and await, we have to carry it all the way up the chain to the top level. So right now, our ViewModel runs asynchronously, as does the JSON service that depends on, but the page or the view is not running asynchronously, waiting for the binding context to be completed. So in order to solve this problem, really we need to continue carrying it up the chain. So if our ViewModel is being initialized asynchronously, we need to tell our page to wait for its initialization task to be completed before we assign the binding context. So we're going to carry this up to the next level. I'm going to do it the same way that we did it on the previous page, by creating a task and a separate asynchronous method that calls on the ViewModel, waits for it to be done initializing, and then assigning it to the binding context after those tasks are complete. So I'll create my task method first. So I'm going to load my ViewModel asynchronously. Now, how are we going to know when the ViewModel is finished loading? Let's go back to the ViewModel. What we're really waiting for is for this task to be completed. Instead of keeping this task private, I'm going to assign it into a public property. That way our ViewModel can notify those depending on it when the task is done. So let's get rid of this private task, and instead we'll make a public property for the task. So we'll have get access, but private set. In this method, we'll change the private task to the public task. So we're still going to offload the initialization into another method, but now the task that it's assigned to is a public property. That means that when we access our ViewModel, we can access that task and wait for it to be completed. First of all, we'll need to maintain access to our ViewModel across these two methods. So let's create a reference to it. Invoice collection ViewModel. That's the ViewModel that's behind this page. Rather than assigning the binding context right away, we're going to assign our local reference to this ViewModel. We also need a task to assign to here. Let's create a private task. And assign it to our load async method. Our loading is where we're going to assign the binding context. We're going to assign the binding context to our local ViewModel, but only after that ViewModel has completed its initialization. So we are going to await the completion of the ViewModel's initialization. Let's put these side by side and compare. Got the page on the right and the ViewModel here on the left. When the page is loading, the dependency injection happens, and we're creating the instance of the ViewModel locally. We store that local instance and then begin the task of loading our ViewModel. when we start loading our ViewModel, we're going to wait for our ViewModel's initialization to be complete before moving on to setting the binding context. So what that means is we're going to go over to the ViewModel's initialization task. The ViewModel's initialization task is not complete until after load invoice items has finished. So once load invoice items is done, invoices is all set up, and then we return back over here and assign the binding context. The binding context is waiting to bind all of those properties to the collection view on the page. So here's our app after making all these changes. You can see at the bottom our count binding, which gives us the total number of invoices, is at 58,764. Not going to scroll through them all, but we can see that that count is being updated at the right time after the collection has already been completely loaded and showing up correctly. So the takeaway from this is just to be careful when you're breaking into threads to make sure that you're not going to affect things down the line that are trying to use the things you're waiting for. The best way to guard against that is to make your way up the chain. Think about when these items are being constructed, when they're being called, and make sure that you're working asynchronously all the way up to the top level. So I hope you found this helpful and informative. If you have any questions, please let me know. Otherwise, we'll see you in the next one.